Okay, everybody, we're now going to talk about what you all want, jobs. One of the reasons you're here is you want jobs in data science, or computer science, or computer engineering, or artificial intelligence engineer, machine learning, data engineer, what have you. These are the jobs that are available today, and the material of this course is an overview of what you have to do to get those jobs. And it's a complement to why we're learning about all these technologies. This is a relatively short section, but hopefully it will motivate you if what you want is jobs. Thank you very much. Let's get on. The first slide is a relatively old one from Microsoft. Well, at least they paid for the results that this survey gave. And it's basically cloud jobs worldwide in millions. And it varies from 6.7 in 2012 to 13.8 in 2015. And you can see it's done by overall by country. China is the highest, India, United States, and then Indonesia is surprisingly perhaps number 4. And the green is the fraction compared to the overall workforce, which is varies actually quite a bit from country to country. And it's 0.7% for the United States, a reasonably high number. But others are lower and higher than this. Australia is 1. We have here Israel at 0.91. Brazil at 0.37. Japan low at 0.4. So anyway, this is a large number of jobs. Its definition is a bit unclear. It may include both running clouds and using clouds, which is the latter especially is pretty nebulous, but they're still jobs. Here is a more precise study from McKinsey on big data jobs or data science jobs, and they have made this interesting analysis of the jobs in 2 categories. They find 140 to 190,000 people in the US needed in deep analytic skills. That's the sort of hardcore computer science area, and 1.5 million in what we would call the decision maker track, or managers or analysts, which are the people with the know-how to actually use big data to make decisions. At IU Informatics, you might say, is sort of training people for the decision maker track, and computer science for the somewhat smaller but critical 140 to 190,000. This plot here has had significant influence and a significant motivation in pursuing data science, certainly at Indiana University. So those numbers were gaps. Here is another plot from an article by Davenport from a talk he gave in Berkeley. This is his very good Berkeley talk series, November 2012. And it's from LinkedIn. I'm not quite certain how LinkedIn got data from 1990. I don't think it existed then. But anyway, this is the some sort of depiction of the growth in analytics and data science growth. And this is in terms of percentage. So it's not a big percentage, 0.1%, but it's obviously growing, and presumably it's growing after 2010 when this particular plot ended. Here is, if we come back to the Mika talk from KPCB, and here she has a plot of the number of graduates in computer science. This must be in the US, which is over 50,000 per year, and the number of job openings requiring a bachelor's degree in computer science, which is, as she says, 2.4 times as many as the number of graduates. This says that not just data science, but the broad area of IT is currently got a huge shortage of people, and that's just saying that the world is becoming is becoming informaticized, or everything X is becoming EX rapidly, and the jobs are in EX. And of course, unfortunately, the jobs in X, which are not EX, are actually going down. That's part of the reason worldwide there's some uncertainty or disruption in things going on. Here, the final slide in this set is again from Meeker. It's just an amusing depiction of the number of jobs, some street view from Silicon Valley, advertising jobs of all sorts of types, director of business development, director of engineering, senior software engineer, DevOps engineer, ... technical sales engineer. And she points out the 5 companies alone, which are not actually, you don't even discuss Facebook, Twitter, Google, which might have even more. These 5 companies, which are mainly the old companies, although Qualcomm is pretty near the front line, Intel, IBM, Microsoft, Oracle, and Qualcomm. Although I'm not trying to be negative about these other companies, they were just established ahead of. They're still obviously leaders in the new areas as well as the old areas. Anyway, those 5 companies have 10,000 openings in the US, and it's those openings that you're being trained to do. And of course, data science is only a small subset of those openings. But so that's the backdrop for this course. That we're living in a world that is becoming an IT world for obvious reasons, and that trend is likely to continue. Thank you. Okay, now let's look at some more recent data, 2017, middle of August. I just printed out the charts that this Nifty site. It actually tells you it's a good place for searching for jobs. And I just looked at various types of jobs. And I was sort of interested at the time at looking at also not only standard jobs such as data scientist, which is here in yellow, but also somewhat less obvious jobs such as machine learning engineer, which is actually a pretty large sample. These, by the way, are percentages of the total job posting, so this is 0.25%. And then we have computer science. Actually, machine learning engineer is somewhat above computer scientist. Big data engineer is up here. Artificial intelligence engineer is not so common, showing that at least in jobs, the word machine learning is probably more powerful than artificial intelligence. So, although of course, in practice, they sort of mean the same thing because you use machine learning to get artificial intelligence. Let's now just contrast this with the next slide. This shows the same big data engineer that we had before at about 0.4%. And here, that's sort of interesting to look at computer engineer, which is around 4%, sitting up here. It's actually gone down. It was over 5% in 2015. Maybe these jobs have gone into the jobs on the previous slide. I don't know. Notice computer science was actually around 0.25%. It was 1/10 of computer engineers. Now, my guess is that many computer engineer jobs, if not the majority, are taken by students with computer science degrees. But it also points out that you always talk about software engineers. You don't talk about software scientists building giant systems. And most of those software engineers have computer science degrees. All right, so there's lots to look forward to if you do practical work in the area of clouds, big data, AI. Now we're off to the next lesson. Thank you very much. This is Geoffrey Fox ending this lesson.